Hello everyone, welcome to my class. In today's class we are starting chapter 6. So let me start the class right away. First, let me give you an overview of chapter 6. In chapter 6 we study about trigonometric identities, inverse trigonometric functions, and general trigonometric equations and applications. First, we learn fundamental trig identities, then sum and difference trig identities, double angle and half angle trig identities, product to sum and sum to product trig identities, inverse trigonometric functions, and we finish the chapter 6 solving basic trig equations as well as general trig equations and applications. So now let's begin section 6.1, trigonometric identities and families of identities. First, definitions. Let me scroll down. A trig identity is a trig equations that is true for all angles in the domain of definitions. By the way, trigonometric equations are conditional equations. They are solvable only for certain angles. So the trigonometric identity is a trig equations that is true for all angles in the domain. Next, fundamental trig identities. We already learned reciprocal trig identities, quotient identities, and even odd trigonometric identities. Let me recall below. Reciprocal identities: sine theta is 1 over cosecant theta, cosine theta is 1 over secant theta, tan theta is 1 over cotangent theta, cosecant theta is 1 over sine theta, secant theta is 1 over cosine theta, cotangent theta is 1 over tan theta. Similarly, quotient identities: tan theta is sine theta over cosine theta, cotangent theta is cosine theta over sine theta, tan theta is secant theta over cosecant theta. Similarly, due to symmetry, the even and odd trigonometric identities: sine of minus theta is minus sine theta, so sine theta is odd function. Similarly, tan theta is odd functions, but cosine theta is even function, since cosine of minus theta turns out to be cosine theta. Great. Next, let's talk about Pythagorean identities. We know sine square theta plus cosine square theta equals to 1. And these following two identities are straightforward. Secant square theta minus tan square theta equals to 1, and cosecant square theta minus cotangent square theta equals to 1. Just quick verify. In this Pythagorean identity, if we divide both sides by cosine square theta, then, which I did here, I divided both sides of this Pythagorean identity by cosine square theta. Then on the left side, we distribute the cosine square theta. So then sine square theta over cosine square theta turns out to be tan square theta. And plus cosine square theta over cosine square theta cancel out, just 1. Similarly, in the right side, 1 over cosine square theta turns out to be secant square theta. So we have this identity: secant square theta minus tan square theta equals to 1. Similarly, if we divide the Pythagorean identity both sides by sine square theta, it gives us this another identity, which is 1 plus cotangent square theta equals to cosecant square theta, or cosecant square theta minus cotangent square theta equals to 1. Great. I hope this makes sense to you all. Now let's move on. Writing one trig function in terms of another trigonometric functions. By Pythagorean identity, we know sine square theta plus cosine square theta equals to 1. We can manipulate this Pythagorean identity. Let's subtract cosine square theta both sides, then this gives us sine square theta equals to 1 minus cosine square theta. Then take the square root. So the sine theta turns out to be plus minus radical 1 minus cosine square theta. Similarly, on this Pythagorean identity, if we subtract sine square theta, then it turns out to be cosine square theta equals to 1 minus sine square theta. Then we can take the square root, then we will get cosine theta equals to plus minus radical 1 minus sine square theta. Great. Next, from this trigonometric identity, tan square theta plus 1 equals to secant square theta, which we have here, then take the square root both sides. It gives us secant theta equals to plus minus radical 1 plus tan square theta. And similarly, by taking the square root on this trig identity, 1 plus cotangent square theta equals to cosecant square theta, we will have cosecant theta equals to plus minus under the radical 1 plus cotangent square theta. I hope this identity makes sense to you all. So now let's move on. Let's do one example here. Example 1, write the trig functions cosine x in terms of tangent x. Let's begin the solutions. So we know cosine x is the reciprocal of secant x, and we know secant x equals to plus minus under the radical 1 plus tan square x. This is the identity which we have here. Awesome. So we expressed cosine x in terms of tangent x. Great. Now let's move on. Verifying a trig identity using algebra skills. Ideas. There are multiple ways to verify a trig identity. In particular, work with the complex side of the equations, as it gives you more to work with, and simplify it to get the other side. Some useful algebra skills are distribute, factor, some special product formula, a minus b times a plus b turns out to be a square minus b square, perfect square formula, a plus b outside square turns out to be a square plus 2ab plus b square. Similarly, a minus b outside square turns out to be a square minus 2ab plus b square. And we can combine the terms in the fractions using LCD. So for example, a over b plus minus c over d turns out to be AD plus minus BC over BD. Great. So now let's work some examples. Example 2. Verify the trig identity. The given trig identity equation is cosine x times secant x minus cosine x equals to sine square x. So let's begin the solutions. So by looking at these trig equations, the left side is slightly complicated than the right side. So let's begin from the left side. So LHS is the left hand side. I just copy the left hand side here. Then I distribute. So the cosine x times secant x, plus times minus is minus. Then cosine x times cosine x is cosine square x. The next step, we know the secant x is the reciprocal of cosine x, so I wrote here. Then I copy the second term, cosine square x, as it is. In the first term here, cosine x cancel out, so we have 1 minus cosine square x, which is by formula sine square x, which is the right hand side, hence we verified. Great. I hope this idea makes sense to you all. Now let's move on. Example 3. Verify another trig identity here. The given trig identity is cosine x times sine x plus cosine x over sine x plus sine square x equals to cotangent x. Begin the solution, start from left hand side, copy the left hand side. Then the next step, in the numerator we have a cosine x, let's factor out the cosine x, then sine x plus 1 inside the parenthesis all over. In the denominator we factor the sine x out, then inside the parenthesis 1 plus sine x left. I hope this step makes sense to you all. Then we can cancel the sine x plus 1 and 1 plus sine x. Then we have cosine x over sine x left, which is cotangent x, which is the right hand side, and should be verified. Great. Now let's move on. Let's do example 4. Verify the given trig identity is secant x over sine x minus cosecant x over secant x equals to tan x. Let's begin the solutions. So here on the left hand side we have two fractions. We need to subtract the two fractions. So the idea is we take LCD. So the LCD turns out to be sine x times secant x. Then secant x times secant x is secant square x. This minus as it is. And sine x times cosecant x is sine x times cosecant x over the LCD sine x times secant x. Now in the next step, here sine x times cosecant x cancel out because cosecant x is 1 over sine x, so sine x cancel. So then secant square, the first term as it is, minus 1 over sine x as it is. We know secant x is 1 over cosine x. Then again we know another trig identity, secant square x minus 1 is tan square x. Let me show you this formula here. We derived here secant square x equals to 1 plus tan square x. I hope this identity makes sense to you all. Now let me scroll down. So the numerator is tan square x over sine x over cosine x turns out to be tan x, and you can cancel the 1 tan x in the numerator and denominator, so we have only 1 tan x left, which is the right hand side, and should be verified. Great. Now let's move on. Let's do example 5. Verify that the given trigonometric equation is not an trigonometric identity. So given trigonometric equation is tangent of 2 theta equals to 2 times tangent theta. So let's begin the solution. So the idea is find an angle theta where left hand side is not equals to right hand side. So here let's pick theta equals to pi 4th. Then the left hand side is tangent of 2 times pi 4th, which is, I can cancel the 2 and 4. So the left hand side is tangent of pi half, which is undefined. We know tangent 90 degrees is undefined, so our left hand side is undefined. Now let's see on the right hand side. So the right hand side is 2 times tangent pi 4th, and we know tangent pi 4th means tangent 45 degree is 1, so 2 times tangent 45 degree is 2 times 1, which is 2. So our right hand side is 2, but our left hand side was undefined, so these two are not equal, hence the given trigonometric equation is not an identity. I hope this makes sense to you all. Now let's move on. Now example 6. For the function secant theta equals to 5 over 3 with theta in 4th quadrant, state the value of other 5 trig functions. To begin the solutions, we know secant theta equals to the ratio of hypotenuse over base, so that means h is 5, base is 3. Then using Pythagorean identity, p square equals to h square minus b square. So h is 5, b is 3, so 5 square minus 3 square, which is 16. So then p value is, taking the square root both sides, p equals to radical 16, which is plus minus 4. Note, in fourth quadrant only cosine theta is positive. Hence, cosine theta equals to, we know the ratio of base over hypotenuse, so b over h. B is 3, h is 5, so 3/5. Now sine theta turns out to be perpendicular over hypotenuse, so p is -4 and h is 5, since sine theta is negative in fourth quadrant. Similarly, tan theta equals to the ratio of perpendicular over base. Perpendicular is -4 and base is 3. Again, keep in mind that tangent theta is negative in fourth quadrant. Similarly, cosecant theta is just the reciprocal of sine theta, so -5/4, and cotangent theta is the reciprocal of tangent theta, -3/4. Great. I hope this makes sense to you all. We finished these sections. Thank you.